Welcome back to part 2 of this short introductory training session on Infinera's XTM series and XTG series Metro platforms. This second section gives a high-level overview of these two platforms. Okay, so let's take a look at Infinera's Metro portfolio. The primary platform here is the XTM series, and this is the cornerstone of the application-specific focus we discussed in the first part of this training. As described in Part 1, the XTM series is a highly flexible packet optical platform with a focus on low power, high density and application-specific capabilities. The XTM series is built on 3 chassis options and some dedicated pizza box and CPU units. The 3 chassis all support the same range of plug-in units and should really be considered as a card cage with power and centralized management. There is a sync backplane but no traffic backplane, so each unit manages all the necessary client and line traffic and any aggregation and switching. This chassis simplicity makes the platform very flexible and keeps complexity down, hence the right-sized economics and low power for Metro access and aggregation. Of course, the lack of a backplane is an issue for some Metro core sites that need even more switching than we can fit on a card, hence the need for a new Metro core platform. But closer to the edge, the simplicity of XTM becomes a real advantage. The chassis support a wide range of single slot and dual slot full height cards. These are mainly traffic cards and larger optical layer cards, and some smaller half height cards, mainly for some optical layer components. The chassis can be reconfigured to support variable amounts of these smaller cards. Let's take a deeper look at the range of traffic units supported by the XTM series. These fall into 3 main categories: Layer 1 transponders, Layer 1 muxponders, and Layer 2 packet optical devices. The transponders support a vast array of traffic services and map each of these to a dedicated wavelength. The most commonly used transponder units are shown here, and the most interesting to new customers and therefore sales folks learning about the product are the 400 gig flexponder and the 2 hex cards that each support 6 transponder functions. The 400 gig flexponder is the newest transponder and part of our XTM2 solution. The unit has dual 200 gig CFP2 DCO modules enabling 2 independent transponders, each supporting 100 gig or 200 gig line rates. Actually, at 200 gig, the traffic acts as a 2x100 gig muxponder, hence the flexponder name. This unit is highly popular in new and existing customers and is key to a number of recent wins. The 2 hex cards both support 6 transponder functions for 10 gig services. One, the hex OTN, is OTN based, and the other, the hex Lite, is based on Infinera's own intelligent WDM or IWDM framing. IWDM framing behaves very much like OTN, but adds a number of benefits. These can vary across the portfolio as IWDM is optimized towards the application. In this case, IWDM gives the hex Lite ultra-low latency of around 4 nanoseconds for a pair of devices. This means using the hex Lite cards only adds the equivalent of about 1 meter of fiber latency to a route, whereas anything OTN based is going to be about 1,000 times higher in the microsecond region at best, so meters become kilometers of equivalent latency. The range of muxponders multiplex multiple lower speed services up to a higher speed line. Again, within our XTM2 solution, we have a 200 gig muxponder using the same 200 gig CFP2 DCO optics, which we released in the summer of 2018. The range of muxponders covers OTN and IWDM framing. Here, IWDM can add benefits including over OTN, such as better latency performance, better wavelength utilization, such as 10 times 1 gig instead of 8 times 1 gig over a 10 gig line, and application-specific functionality, such as the front-haul specific capabilities we discussed in Part 1. Lastly, we have the Layer 2 packet optical devices. These include our range of packet optical transport switches, the EMXPs, and also some additional devices. These include a range of demarcation devices, the high-performance Ethernet demarcation units, EDUs, and the simpler and therefore cheaper network interface devices, or NIDs, all of which provide CPE capabilities to terminate Ethernet services at a customer premise or cell site. We also have a range of intelligent SFP pluggable optics, the ISFPs. These contain all the necessary functionality to support TDM services over a packet network. This means legacy SDH or SONET services can easily be supported in parallel to Ethernet services, enabling network operators to migrate legacy services and decommission expensive old SDH SONET networks that are still there to support a gradually diminishing number of customers. Looking at the EMXPs in more detail, these are essentially a range of switch-on-a-blade devices that support a common software and feature set, with the main differences being how big the switch is and the associated I/O options. The range is widely deployed with over 100,000 ports deployed in active networks. The EMXP range currently covers switching sizes from 48 gig for 1 gig to 10 gig aggregation applications, up to the most recent addition, the EMXP 440, which supports dual 100 gig or 200 gig lines and up to 24 10 gig lower speed ports. Again, this is part of the XTM2 initiative and was one of the quickest ramping units ever within the XTM series. Early customers included a new customer carrying all the World Cup football TV traffic to the whole of Europe, so certainly mission critical in many people's eyes. This range plays a key role in many of the applications we discussed in part 1 and is a real differentiator for the XTM series. They are designed for lean packet environment where Ethernet capabilities are needed but transport performance is key. So they don't have the same functionalities as most other Ethernet switches. They have smaller queues, less buffering, etc. But the benefits of this is the lower latency, virtually zero jitter, which is the measure of how latency changes over time, and far superior sync performance. When these performance metrics matter, then the EMXP range is industry leading. I've mentioned XTM2 a few times now, so I'll quickly explain the use of the name. In 2017, we launched our new range of 200 gig capable traffic units, the 400 gig FlexBonder, 200 gig MUXBonder and EMXP 440. At the same time, we were starting the migration to the Metro optimized FlexGrid in the optical layer, enabling the optical layer to be prepared for the higher order modulation formats we'll see above 200 gig, and also adding more SDN control capabilities to the platform. Combined, these capabilities were a significant step forward for the XTM series, so we collectively labelled these as XTM2. I've mentioned low power a few times, and the 400 gig FlexBonder in XTM2 is a great example. This card draws less than 80 watts including optics, so that's less than 20 watts per 100 gig service. When we include the worst case scenario in a chassis, we have a figure of 27 watts per 100 gig. This is at 55 degrees C with all the fans going at full speed. And when we compare this to the leading competitors for comparable chassis-based multi-service WDM platforms, we believe these competitors draw almost double the power and in some cases a lot more. Perhaps more importantly though, is the knock-on effect of low power transport on the power and fuse requirements for the chassis. As the industry has pushed the density of solutions up, even though we've all been lowering the power per gig to varying degrees, this hasn't been able to keep up with the density increases. And this means that our systems need much more power per slot into the chassis. And this includes the XTM series, where over recent years we've increased the power into the chassis to support the massive jumps we've made in the traffic per slot. Initially it was 10 gigs, and today we support 400 gigs. Anyway, this creates a huge challenge for network operators. As while they like the lower operating costs associated with lower power, they are often restricted in what they can actually deploy based on the available power feeds into a site. Power upgrades are hugely expensive, especially in co-location spaces, so being able to deploy a 400 gig capable card in a chassis that only needs 5, 15 or 25 amp fuses is a huge advantage. This is a clear competitive advantage of the XTM series, and we can quite simply deploy high capacity optics into space and power constrained environments that some of our competitors can't. In part 1 of this training session, I mentioned we'll be launching a new solution for DAA networks in October 2018. This solution spans the full range of the DAA network needs, and the newest part of the solution is a new device optimized for 10 gig to 100 gig aggregation. So let's take a quick look at this, the High Density Ethernet Aggregator, or HDEA. This device reuses a lot of the software from the EMXP software base, meaning it supports a broad range of Ethernet and synchronization capabilities to support DAA and other applications like 5G aggregation. It is designed to increase the density and simplify operations in sites that need a large volume of 10 gig to 100 gig aggregation. The HDEA supports a 1.6 terabit switch with 80 times 10 gig and 8 times 100 gig to perform that 10 gig to 100 gig aggregation function. and it overcomes the limitations of front plate space with a unique pull-out mechanical design. This allows the HDA to be pulled out of the rack in service to give access to both the sides and the rear of the unit. This allows us to use the sides to house the 80 times 10 gig SFPs that we need, and even access the rear if we need to replace the fans. This is approximately double the density of alternative solutions, and it also draws around half the power. In these applications, the bulk of the fibers within the rack support 10 gig wavelengths between the MUX/DMUX units from the access fibers and the devices that aggregate these 10 gig services up to 100 gig, like the HDA. To address this, the HDA uses multi-fiber push-on or MPO cables to connect to specific MPO-based high-density MUX/DMUX filter units, meaning that a single cable can replace up to 20 individual fibers. This has a massively positive impact on the initial installation and ongoing maintenance of these types of networks. The HDA will also support our new Auto Lambda optics. These optics are WDM POM based auto-tunable optics that learn their colour from the network, allowing field technicians to treat them as virtually grey optics. This has a big impact on simplifying network rollout and maintenance, reducing installation errors and managing sparing costs. Some of these fibre deep access networks for DAA or 5G will eventually have hundreds of thousands or possibly even millions of DWDM endpoints. So every step we can take to simplify operations and reduce costs has a massive impact on these networks. That concludes a very high level overview of the XTM series. Now let's take a look at the XTG series. The XTG series is very tightly coupled with the XTM series and is designed to push these networks deeper into the access fibre plant. XTG uses exactly the same DWDM and CWDM wavelength grids as XTM, meaning that fibres can have XTM at one end and XTG at the other. Essentially, XTG is a range of passive WDM components, meaning they're totally unpowered, that we can deploy in a wide range of environments, from central offices and street cabinets, mounted on walls in locations such as power facilities, or even out in the street under manhole covers. And this really pushes DWDM right out close to the customer. Even though these units are unpowered, we can still support inventory of them through our management system so customers can track their optical networks. To achieve this, the range includes some simple chassis options with chassis mounted filters. We have some enclosed modules and splice tray options that allow filters to be deployed in a range of hermetically sealed enclosures for those manhole type deployments. It sounds simple enough, but XTG isn't just any old range of passive filters. It's designed for the demanding telco customers. XTG is designed to meet those telco requirements with features such as monitoring ports on all devices, extended temperature range support, and very high density. We also often work closely with our customers to customize the range to meet their specific requirements or application. We have over 140,000 units deployed, from simple point-to-point networks to a large European PTT that has tens of thousands of these in a national passive WDM access network. So that concludes this introductory training session on Infinera's Metro portfolio. In part 1, we introduced the high-level value proposition of the portfolio and looked at the applications it supports, and in part 2 we looked at the products themselves in a little more detail. Overall, the application-specific nature of the XTM series gives the platform and our customers an edge in differentiated service delivery. Packet optical is a key differentiator and one that has played a major role in a lot of our new customer wins recently. Low power and high density are things that every vendor claims, so who wouldn't? But these are areas where we have industry-leading numbers to back up our claims, and we can win deals where this is critical. Thanks for spending time to run through these 2 training modules. Good luck selling.